हेलो, वालेकुम अस्सलाम। अहमद आ जाओ जरा, वो मैंने लिंक भेजा है मेरे लेक्चर का। हेलो, ऐसा कह रहे हैं लेक्चर में आओ।
ठीक है जी। अस्सलाम वालेकुम डॉक्टर साहब, if you are hearing me you can now switch on your audio and video. हाँ जी, I can see you. ठीक है जी, ठीक है।
अस्सलाम वालेकुम जी डॉक्टर। ये सो दैट्स अस्सलाम वालेकुम, कैसे हैं आप?
बस जी ठीक ठाक। पार्टिसिपेंट्स आ रहे हैं, 2:04 हो गए। अमूमन 2:05-6 तक सारे पूरे हो जाते हैं। हैवी रजिस्ट्रेशन है तो मैं वैसे 2-3 मिनट दे रहा हूँ ताकि अनाउंसमेंट में एक ही दफा करूँ, बार बार ना करनी पड़े जी। तो मैं जस्ट
I think this is a great initiative. It's a beautiful initiative. Yeah, I think, and you have carried on for so many years that's something.
We are continuing this initiative for the last 4 or 5 years, I think now, and अब एक नया सिलसिला भी शुरू कर रहे हैं जी। वी आर ट्राइंग टू सेट अप अनदर, ये पैनल डिस्कशन शुरू करने लगे हैं और वो भी मेरे ख्याल में इन अनदर 1.5 मंथ पहली पैनल एक हो चुकी है, एक पैनल डिस्कशन। बट उसमें मैं कुछ टेक्निकल प्रॉब्लम्स आ गई थी ऑडियो और ये चीज़ों की। दैट वाज ऑन टॉल बिल्डिंग्स। So now we are going to have a panel discussion on this Basha Dam, inshallah, and इस पे चीजें फाइनलाइज हो रही हैं एंड इंशाल्लाह जल्दी ये एक पैनल डिस्कशन आप देखेंगे। एक नया प्रोग्राम शुरू करने लगे हैं जी। तो
That's wonderful. Yeah. I can see Rizwan is also joining in. Rizwan, Assalamu alaikum.
हाँ जी, रिजवान इज देयर एंड वसीम अमूमन मेरे पास ही बैठ के लेक्चर सुनते हैं. डॉक्टर रियाज अख्तर ये भी हमारे क्लास फेलो हैं. He's there. Suhail Raza is there. He's in the car, I think. And
जी, वो he's driving, I can see.
ये देखें आ रहा है फेसबुक पे. मेरे पास क्लियर सिग्नल है. फेसबुक पे आ रही है लाइव.
We are also recording, I guess.
जी, we are recording it and we will send you the recording.
Sure.
ये सर फेसबुक पे भी लाइव टेलीकास्ट हो रहा है इस वक्त साइमल्टेनियसली जूम के साथ साथ. तो फेसबुक पे भी रिकॉर्ड और उसी पे हम रिकॉर्डिंग रखते हैं फेसबुक पे. जी ठीक है जी. इट लुक्स लाइक a number of audience are available now, so I'm going to start it formally. Ji. Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious and the most merciful. Ladies and gentlemen, Assalamu alaikum and good afternoon. On behalf of Pakistan Society of Civil Engineers, it is our pleasure to welcome all attendees, including those joining us via Facebook. Today, we are presenting lecture number 74 in our ongoing monthly series, a tradition we have upheld consistently since 2020. These lectures are part of PSCE's commitment to fostering knowledge exchange, offering both emerging and experienced engineers the latest insights across various civil engineering disciplines. We encourage all participants to join us in our mission to strengthen PSCE as a dynamic and influential platform dedicated to the advancement and dissemination of knowledge. Before I introduce to you the speaker and the topic, I have to announce the rules of this webinar as per instructions given to us by Pakistan Engineering Council. The first one is participants. All the participants registered for CPD points are required to appear live on webcam. However, female participants have the option to cover their faces if they wish while appearing live. To ensure a smooth session, the microphones of all participants, except the speaker, will remain muted throughout the lecture. Dr. Sahab, I just forgot to ask you, how would you prefer the question answer session, which is normally at the end, a 20-minute question answer session? Would you like slide by slide, or at the end, the question should be asked?
I think it's up to you. I mean, whatever is your normal practice, we'll just follow that.
Okay, sir. Thank you. A dedicated 20-minute question answer session will take place at the end of the lecture. Please note that questions during the lecture should be submitted via the chat box only. At the end of the lecture, I shall read the questions which the guest speaker will answer. However, if I find any question pertinent to be asked during the lecture, that would be my prerogative, and I will ask the question, and inshallah, Dr. Saab will answer that question. Participants joining via Facebook may submit their questions exclusively through the chat box. Now, today's topic. Today's topic is from engineering school to practice, training needs of a civil engineer in shifting paradigms. And our guest speaker is Dr. Nadeem Anwar. His academic qualifications are: he is Doctor of Engineering from Asian Institute of Technology, Bangkok, Thailand, and from the same institute he did his master's. While his bachelor's in civil engineering is from University of Engineering and Technology, Lahore, Pakistan. Dr. Naveed Anwar, a Pakistani-born structural engineer, is the senior advisor to the president of Asian Institute of Technology and CEO of CSI, Bangkok. At AIT, he leads the establishment of a new school of professional practice, teaches master's and PhD courses in structural and earthquake engineering, coordinates academic programs, and advises research students. As CEO, he manages the development of engineering software applications. With over 40 years of experience, Dr. Anwar has excelled in teaching, research supervision, software development, capacity building, and leading international civil and structural engineering projects across 20 plus countries. He has authored 100 plus publications, supervised 50 plus masters and PhD theses, and delivered 100 plus seminars and workshops attended by thousands of engineers globally. At AIT, he has spearheaded initiatives such as ACE Comms, AIT Solutions, iLab collaboration with HEC Pakistan, capacity building programs in Afghanistan, and the development of AIT Share platform for online education. His works extends to collaboration with ADB, World Bank, UNESCO, and other global organizations, as well as involvement with California-based Computers and Structures Incorporated. Dr. Anwar's expertise includes finite element modeling, advanced concrete design, performance-based building of tall buildings, performance-based design of tall buildings, bridge design, and the integration of technologies like IoT, machine learning, and mobile computing into structural engineering. Now, this was a very brief introduction of Dr. Dr. Naveed Anwar, and inshallah, he will now deliver his lecture, and I hope you will enjoy this lecture. Dr. Saab, the floor is yours. Please continue.
Thank you so much, Sultan Sahab, and everyone who is joining us. It's always a pleasure and an honor to join this. This is my second time, and I hope that I will be able to contribute in future talks as well. So first of all, this is a topic, as you can see, it's not a highly technical topic, but it's a very, very important one because it relates to our profession, how we sort of do our work, and most importantly, how our work is finally used by the society, because it's kind of a big picture talk, and it's based mostly on my own personal experience. And working as a structural engineer, as an academician, and also as a software developing sort of professional, I think over many years, many things have accumulated that I want to share with everyone here. So the topic basically is that what can the engineers learn for the future, and even now, because learning is never too late in the shifting paradigms. And so I want to start in the reverse order. First of all, I would like to just highlight some of the shifting paradigms that we are talking about, and then we will see what the education in the universities can be, can achieve, and what we can do on our own, what are the skills that are valuable, and so on. So, and like I said, it's a kind of a personal perspective, so I will also share some of the personal experiences. So let's start. Luckily, we have enough time, so I don't need to rush. Let's start with the shifting paradigms, that what is really shifting? What do we mean by shifting paradigms in this context? Now, let's start historically on, from the first agricultural revolution, which was something like 10,000 years ago, when, human beings moved and started farming or started agriculture. And then the next second agricultural revolution,
Dr. Saab, we can't hear you.
Connect हो गए।
डॉक्टर साहब डिस्कनेक्ट हो गए?
कहते थे कि मैं connect कर रहा हूँ दोबारा।
अच्छा, नहीं सारे प्लीज नहीं बढ़ते, डॉक्टर साहब भी डिस्कनेक्ट हुए हैं. Ladies and gentlemen, there is an interruption. Dr. Saab has been disconnected from the system, so we are waiting for him to rejoin. I'm sorry for this interruption. Inshallah, soon this technical hitch will be resolved. Gigi, welcome, Dr. Saab. Can you hear me?
I think some crash happened on the computer just at the wrong time. So can you see my screen?
Yeah, you can. We can see the screen and we can hear you well. Inshallah, continue.
My apologies. There's something. I think the new Windows update has been causing this. Anyway, so I was mentioning that it took almost 12,000 years for the first major change to happen, and during that time, obviously, there wasn't any change in the way that people do their agriculture or their work. So every generation almost had similar experience. And then after the first agricultural revolution, we saw the first industrial revolution, which was not too far away. And then the second one, and then the third one, and then the fourth one, and now we are into the fifth industrial revolution. So you can see that after that, the change in the development is very, very fast, and something that took 12,000 years, in which not much changed. We see a major change in 350 years, in which five revolutions have already come and gone, and more are coming. And more important is the last one, which is from the fourth to the fifth is only less than 25 years. So which means that things are changing around us at a very, very accelerated rate, which means that anything that we did a few years back may not work in the new environment. So the paradigms are shifting, the way things are done are shifting, what is the expectation of the society is shifting. So everything is shifting very, very rapidly. So such an accelerated change demands that every profession, every industry adapts quickly to that. And that's where we are having so much difficulty in many areas. So going back once again to the same story, but from a different angle, from the establishment of the universities and the formal education. The first university was something around 1200 or 1000 years ago, the formal university in Europe, in Italy. And then at that time, subjects that they were teaching were natural philosophy, logic, medicine, theology, mathematics, something like that. most of the subjects, once again, are not technology oriented or not engineering oriented, and they don't change much over the years because they are based on the social sciences and all on other subjects which do not change overnight or do not change rapidly. So this has been going on for thousand years or so until the last century, until this century. And if you just look at Oxford and these disciplines, they produced a lot of notable people just from one university. So there are a few universities that basically controlled most of the development and the human resources, the top human resources that was produced. So, which means that the university itself, education itself, now is undergoing or has undergone a rapid change as well. So, for all these 5 industrial revolutions, the features that have happened, which I've listed here, based, for example, the introduction of steam engines, the electricity, the combustion engines, the digital revolution starting from the third one in the 80s, just very recently, and then fourth revolution with AI, big data, robotics, and all. And now we are into the 5th revolution, and we don't know where things are going really. And what is interesting is that during these revolutions, the subject taught have also been evolving. So engineering started somewhere, 100 years ago or so, formal 102 years ago, 150 years ago, and then business schools established, and after that, computer science, then entrepreneurship. Then there was a whole time of startups and incubation, and we saw so many people moving towards startups and incubation, entrepreneurship. Universities started to teach this. The innovation centers started to set up. The incubation, environment was created, and so many universities rushed to capitalize on this phase of development. The startup phase is fading away, as you know. It's not the same scene as it was a few years back. And now in the 5th industrial revolution, we don't know what exactly is to be taught because things are changing so rapidly and so many new things are coming up. So that's the bigger picture of the university education, which sort of relates to the changing environment around us. Now, if I just take one example from civil engineering, this is most civil engineers and especially structural engineers would be familiar with this basic development of the equation, the force and displacement equilibrium equation, F is equal to KU. This equation took roughly 200 years to reach this form from the day it was originally conceived by Galileo, the concept. And finally, until Thomas Young, it was almost 200 years. So you can see that even in our own discipline, things develop, our own discipline, the basic knowledge developed rather slowly until recently. And there was the concepts were there, but the formulations weren't developed properly, and the math wasn't complete until very recently. So you can see here that it's not just the other technology, but engineering itself has developed even the fundamentals rather slowly in the past. Now let's come to 2 major changes that are affecting everything and also affecting what we are going to talk about. The first one is, of course, advancement in AI. And this happened over a span of 70 years. AI, from the 1950s to now, it has come and gone several times. So there were several cycles in which people thought that we have AI, but even though we had the computing logic, we didn't have the infrastructure to do the computing, to do the data crunching. As you can see right now, even the energy isn't enough to run the data centers that are doing the computing, the chip manufacturing. So the whole infrastructure is still developing, catching up. So even though the concepts were there, but now it seems that everything is coming together, and AI has actually really become very powerful compared to its previous cycles. But it took, it started 70 years ago, and it has gone up and down. But now this has become one of the most significant development of our recent times, which I think is something that we can't deny anymore. And you can see the amount of effort, the money, and talent being diverted toward this development. So this is one major paradigm change that we are going to talk about, or we talk about. that we have to address. The second one is the climate change and sustainability awareness. And this is also not very old. This is almost the same, 60 years, 70 years old. So people didn't really think about this much in the 50s, and this has started. So it's to me, it's quite interesting to see that both of them, the AI revolution or AI awareness and AI development, and the awareness about climate change, sustainability, they started more or less at the same time and have developed in the same manner very, very rapidly. And so much has happened on climate change awareness and the research done on that and the focus on that. And I've said in the last talk also, and I'm saying once again, that civil engineering probably lost out on this opportunity, because climate change and sustainability is something that civil engineering could have easily capitalized a lot if more attention would have been paid to this education or integration of this one into our curriculum, into our work, and so on. Because I think this is very much related to what we as civil engineers do. You can see a lot of that is related to our work. But we are not, civil engineers are not leading this initiative. Other people have come in and have started to lead this one. And we have seen the Millennium Development Goals developed and the SDGs now, and we have seen so many initiatives, all in a very short time in the historical timeline. It's just a fraction of a second if you really look at the total time span for the human existence. So AI and climate change and sustainability, these are the two biggest paradigm changes around us, which I think we have to react to, or we have to adapt, or we have to address. And both of them, I think, in civil engineering, I personally feel is not being done enough, or not being done fast enough. So now we are in an age dominated by digital advancements, and we have global challenges. And now it's imperative that we think deeply about the our future trajectory. And people have started to talk about it. And last time also, we also talked about this, about the future proofing. So this is quite clear now that both these major paradigm changes need to be addressed at every level that we operate. Now, before I go to civil engineering, I have two disciplines that I want to mention. It's a slight digression, but I think it's important, because I want to give the examples of the disciplines that have really, really progressed extremely fast, much faster than we can imagine. In fact, civil engineering hasn't really changed that much in the last 70, 100 years. Our research is similar. Things are changing a little bit, but on the ground, that you can't see much change. We're still doing a lot of things in almost the same way. But look at aviation history. They have changed. They have gone from first flight, 12-second flight, to the James Webb Space Telescope launch in 120 years or less. It includes, if you look at that, which includes the making of this huge aircraft, very fast aircraft, going to the space, having a space station, and landing on the moon. And I think the most amazing feat of engineering and science is the launch of the Webb telescope, which was sent millions of kilometers away, assembled there remotely, precisely. And that, I think, is just amazing. And this is how the science, technology, engineering, math, and everything has really come into play, including the manufacturing and including the actually demonstrating the technology. So I think aviation industry, space industry, this is something that is the development which boggles the mind if you just look at the first flight and what is happening currently. So this is one that I think we should look at. The second one that also fascinates me is the biomedical engineering and the finite element analysis they are using. We as structural and civil engineers think that we do finite element analysis, but we do, with due apologies to my colleagues, we do very, very rough work compared to what the colleagues are doing in biomedical and other applications. If you see their models, if you see what they are capable of doing, our models are so crude. We make so many approximations. We make we put for factor of safety everywhere. We add factors wherever we don't understand anything. We change, we convert huge beams or piers into frame elements, and we do all that refinements, all that approximations. And whereas, people working in other fields also using finite element analysis, which structural civil engineers claim to have developed in a much, much refined manner. And I actually went to NUST a couple of weeks ago, the last 2 weeks ago, and I went to their center, the Science and Technology Park, and there was their Center for Biomedical Engineering, and the director was showing me the kind of finite element analysis they are doing and matching it with the real motion capture, and predicting the health of the people and the bone density and then bone sort of decay, all using the same finite element analysis that we use and similar software. So I think that's another area where our other disciplines have gone way ahead of us by adopting, taking technology into their disciplines. So coming back to our field now, to civil engineering education. So let me start with the civil engineering education and the universities and see what can be done at the university level, or what is it that the universities could be addressing. And then we will move on to the skills that we need. So if you search what are the top most respected jobs in the world, you will find that these are the list or similar list you will come up. Doctors, nurses, lawyers, policemen, firemen, professors, scientists, and researchers. I think this is quite clear. If you watch any movies or you watch any television series, who are the heroes? You hardly see a civil engineer or a structural engineer to be the main character in a drama or in a movie, or the hero. And that shows how the public views our profession on our people. They don't find it interesting. They don't find it challenging. They don't find it important. So there are no stories about what we do and the people that we are. So that gives you some idea of how our profession isn't the top one in the public eye, in the perception. If you look at the characteristics of a recognized profession, we actually fill the sort of definition. It's a body of knowledge and behaviors and skills and a professional culture needed to practice a profession. And it revolves on knowledge and skills. But somehow our profession is not really recognized well. If you compare architects, our closest brothers or sisters, they are much more appealing to the public than engineers. I do understand that in our traditional culture, engineers and doctors have always been given emphasis in terms of what we should study. But if you really see how the public in the end views it, you will see that our recognition is still less than many other professions. And there's a reason for that, and that's what we are going to discuss. So there are three key elements of a professional image which are part of the discussion today. The first one is ethics, second, morals, and then standards of behavior. So I think we all know that on these three levels, civil engineers are not the best in many ways. We are not viewed as people with very high, ethics or moral, for whatever reason. I don't want to go into that side, but somehow there is an image problem with the way that our colleagues or we work in the profession. So that's something that needs to be addressed at a very, sort of a bigger level, at a professional level. And the societies like this can do a lot in that. So this is related to our profession and our image. And that is where we have to improve, or we have to go, or we have to achieve. To do that, so we want to make civil engineering as a recognized profession with an acceptable image in public's eye, or a very high image because as a profession we should have pride on that, and we do. But if you talk to the people, you don't see the same recognition that we should be getting. So where do we start? Obviously, the start is that what is the actual and perceived role of civil and structural engineers? We have to make sure that society understands what we are doing and we promote what we are doing. I think you might have seen whenever something happens, if some disaster happens, some earthquake happens, even a collapse happens, it's always other people who come to talk about it on the television or the media. Structural engineers or civil engineers are not the one talking about it. I sometimes see lawyers, sometimes see architects, sometimes see even just journalists with no knowledge of engineering talking about the engineering issues at that point. And that, I think that's one of the thing that we need to see. We need to speak about what's happening, which is of public interest, and give our opinion in that. And that requires skills beyond what we are taught, and something that we will focus today. Second is, what is it that civil and structural engineers should learn in this direction, and then how they can learn it effectively and continuously. So these are the basic questions that we are looking at. Now, if you look at our main organization around the world, as you know, is the PSCE, American Society of Civil Engineers, and many professionals, many people look up to this one. So they published this book recently on civil engineering body of knowledge for 21st century, preparing the civil engineer for the future. I think it's a great initiative because they're talking about it, and they set up a committee to look into that. And then they came up with a book with a lot of information. So I just give you a couple of key slides from there. The first one is that they define what subjects should be taught at foundation, in technical, and as professional, and at what degree they should be taught at. And they talk about knowledge, comprehension, application, synthesis, evaluation, and so on. And they're saying they talk at bachelor degree or master's degree and at the professional engineering degree. So they try to create a roadmap for engineers to learn various things for various purposes at various levels. So this is kind of a summary of what the document says. And they also identified that knowledge, to start with, comprehension of the knowledge, the application of the knowledge, analysis of what is going on and what has happened, synthesis of the information, and finally an evaluation should be done in the development in terms of the achievement, career achievements. And we have foundational, technical, and professional knowledge. So this is the overall roadmap from the ASC developed recently. So it's a very good document for universities, for professional bodies to look at and to follow. But I will not go into the detail because I said I want to make it more personal, experience-based. So my first question is, having worked in the university for 30 years or so, my first question is, and is making graduates career ready the job of the university education or not? Are the universities going to give education just for the sake of education, or should they prepare the people for the job? This is a question that is discussed a lot in the academic councils, academic senates, in our university, in many universities. What should be the purpose of the education of the universities? So let's see. If you look at that, there are three parts, three interlocking items in this process. One is education, one is qualification, and one is skill. And they are very different, and at the same time, they are connected, and one depends on the other, but they are completely independent in their own right. So education provides the foundation, qualification validates the knowledge, and skills demonstrate the practical capability. So all three will be necessary if we want to utilize this process or this total gain from that. And this is where the educational institutions differ in their focus and in their achievement. So education obviously is not, it should not be, or is not, education is not about getting a degree. It's about learning to learn, because no universities can teach everything that we are going to use in our lifetime. So they can only teach us, give us the education on how to learn later. So it's a learning to learn process. Because whatever we learn, we just forget. And when I teach my course, after one lecture, when I ask the students of the previous lecture, they've already forgotten about it. So the actual text or actual details will not be remembered. But the concepts and the ability to learn is the one that we are looking at. Qualifications are milestones, but not real end goals. Actually, I think all of us who are working in practice know that nobody cares for our degrees. My own degrees were lost in the flood of many years ago, and I don't have any paper left with me. And that's something that nobody wants to see anymore. Our grades, our qualification, once we enter the field, they become kind of irrelevant most of the time. So qualification is necessary in a way, but it's not the end. It's just a stepping stone. Skills are the key because these are the practical manifestation of education and qualification. So if we don't carry the skills with us, then we can't utilize our knowledge and our education, because that's ultimately what, even teaching is a skill. So if we have got that, then we can teach. Even we have the ability, we have the knowledge. If we can't deliver the lecture, then we are not going to be able to impart education. So education, teaching is a skill together with the knowledge. So all these three elements are needed. And this is, I think, the key, important message that universities sometimes do not completely cover. Some universities focus, like we have these vocational schools that focus on skills, and certain universities focus only on education. And of course, degree is one thing. So education without skills is theoretical knowledge without practical application. And a lot of people in the industry complain about the university education. They don't complain about the others, but they complain about education, that it's not relevant, the students are not useful at the job. Skills without education, limited problem-solving ability. So that's why the vocational institutions give the skills, but no education, so they can only solve simple problems. So the ability is not high. So that means that also doesn't really work in all cases. Qualification without skill is just a paper, which actually has no meaning. When we hire people, I almost never ask them about the degree. We don't even know. In fact, it's an interesting thing that 3 of our students in AIT who took master's program never finished, but they got the job and they're doing great in Bangkok, and nobody asked them for the degree. They left after taking the courses. They didn't finish, but they didn't care because nobody asked the paper from them. So because they had learned, so that was good enough. They had the skills, and that was good enough for the industry. So this is the balancing problem that every academic institution is facing, how to balance between fundamental knowledge, the domain knowledge of a particular subject, the hard skills, and the soft skills. And most of the time, we compromise on the soft skills. And then after, soft skills are compromised almost all the time. And that's what is significantly more important in the long run. Hard skills are provided, but mostly people learn it on the job. But soft skills are the one that we miss out quite a bit. And I will mention more about that. So making graduates career ready is for them to have the ability to choose careers, have the passion and the training, and have the skills to do the job they need to do. And then having the ability to adapt as the world changes around them. And we have seen that the world is changing around us very rapidly. So they need to have the ability to learn to adapt during this change. Now, this is a big question here. And I think this is interesting that it's not clear. Should we choose a career first and then get the education for that career, or we get the education first, whatever is available, and then we choose a career that matches with the education? And this is where I'm sure senior colleagues, friends here, people, their relatives, people come to ask you, what should my child do? They are now finishing under metric or FSC, where should they go? Which field should they choose? What profession should they choose? Both of these choices are hard. Some people choose the education first and then try to find a job to match with that. And sometimes there isn't any job to match with a particular type of education. And sometimes they choose a career and then they don't have the right education to match with that. So both of them are difficult choices, difficult questions, and each leads to its own problems. So very considerable, I think, focus should be given on these two questions and make the choice correctly early on. And then there's a big problem here, the time lag between the start of the choice and the start of the actual work. There are many steps: choosing the minor, major, first degree, deciding the career, graduate degree, finding the job, and progression through the job. So you have like 6 to 8 years time lag here, and then another 35 plus years time lag over there. So during that time, things already changed. I remember very well that when MBA was a big thing, everybody wants to go to MBA. By the time they finish, the market is overpopulated with MBAs and they can't find a job because they think MBA has a great potential. Similarly, there was a big time for telecom engineering, and everybody rushed to telecom engineering. And then by the time they finish, the market was already full and the telecom had passed its peak. So many times we choose a career or choose an education, and because of the time lag, by the time we reach the goal, it's no longer the relevant field. And once we select a career, then we also see all these changes. So that's why career is a lifelong endeavor, and lifelong learning is very important. And this talk is so important in that path, because everyone who is attending this one is actually attending because they realize that this is a lifelong endeavor, and they need to continue to learn. And there's a lot of effort being done on this particular one. So what the universities can do is to design appropriate programs, number one, offer appropriate learning paths for different people, then provide counseling, provide student assistantships, internships, career fairs, and so on. So let's just quickly go over this one. This is a course outline that I prepared a few years ago for a university to offer a civil engineering program. And this hierarchy takes into account all of the discussion that we are having. So the idea was that right from the beginning, there's an exposure to SDGs, all of the aesthetics and ethics and law and community development, all of the items which are missing in our work that are important in the end. So we should have this common ground where everybody is exposed to these aspects of the profession right from the beginning. Then we have knowledge and skills in IT, in communication, in management, innovation, entrepreneurship, leadership, computer-aided design, and all built on top of that, again, common for everyone. Then strong base in math, stats, physics, chemistry, and so on. All of those things, we need to have a layer of that one. And then we have a layer of subjects in dynamics, geology, and particular verticals that we want to choose. And the verticals could be national infrastructure, transportation, planning, and so on, urban infrastructure, water cycle, international projects, special areas, and so on. So universities could provide a base, a multi-layer base, and then after that, build verticals on that, and people can choose those verticals, but everyone should have a foundation. And right now, what we are often missing is the first layer, which isn't there. We start with strong subjects already and missing the soft areas, and universities are now adding these into their curricula. The problem is that there's a certain amount of time, so some courses have to go to make room for this one. So this is a model that was prepared a few years back for a university's new civil engineering program. So that's the design of the program that we are talking about. The second one is the credit structure. That is also very important, that people can choose the credit structure that suits their needs. They want to go into teaching, they have an academic career or research career, another path. If they want to go to industry, then there's a profession, then there's another path. But right now, often we don't have this distinction. So people come out with a similar education and skills, but their job is widely different. So that's another area where the universities can have the courses, research, exchange, internships, and project organized in such a way that they feed into two very different oriented jobs that people are, or careers people are looking for when they finish the university education. So that's the second part. The first one is a design programs, which are comprehensive and include all of the things that we talked about, and then give the students a flexibility in choosing which direction they want to follow. And then on top of that, then universities are offering, and especially AIT also, are offering professional master's programs of different kinds. So traditional masters, open masters, flexible masters, and professional masters. And this is where I feel the strength of the education lies, to adapt to the changing paradigms that we talked about, because these open masters, flexible masters, and professional masters can be created every 2-3 years, depending upon what is needed. So these are not the traditional masters. So they are designed to adapt or respond to the changing needs of the industry, and also changing needs of the things going around us, especially open masters. People can create their own masters by just taking the courses away and have their own degree in their own way that they want to follow. And same is the case with flexible and professional. So I think that's the third piece of the puzzle. The first one is the program, second one is the flexibility, and the third one is that in terms of the higher education, there should be more adaptability for the courses. Now, I want to show you one practical example of how this is done at AIT, and I'm involved in almost all of this process, and that is the AIT's experience in structural engineering, where we have tried to do all of that. So first of all, we have a wind tunnel lab, which is a testing facility. Then we have a structural lab with all of the related things. And then we have the teaching and research in tall buildings, wind and earthquake engineering. And then we have a practical experience of over 1,000 or 100 or 200 projects through AIT solutions. So we bring that together as a cycle where external partners, computers and structures, CSI, they also come in, and we have external consultants, and we create this whole knowledge cycle, which has practical input from outside. It has the research labs, and it has the research, which is all integrated and feeding into each other. And for the last 15, 20 years, we have seen this model work very well. And that's why the graduates that we have, they have practical knowledge, they have understanding, they have lab, they have connection, they have industry, they have a lot. And recently, when we had some difficulty in AIT's enrollment, structural engineering program never went down. We have never had, lack of students in our program, even though data science and many things are coming up. But structural engineering master's programs in AIT is still always in a high demand, and we have always enough students there. So that is a demonstration that this kind of cycle, which is something that the students find valuable. Similarly, we can have, I will go fast on this one, we can have exchange programs with various universities, and then we can have the connection to the employer, the learning, we can go that, career counseling can come in over there, mentorship can come into that. So all these things the universities have and should have, some not to that extent, but these are very important because we are trying to make the graduates, expose them and make them ready for the real world. So expert talks and alumni and peers, like Big Brother kind of a program, so many programs can run. Internships are so important because they actually go out, and this is what the business schools do quite a lot. Engineering schools, probably not that much. They always have at least one semester where the students need to go out, work in a company, get experience, and then come back. So internships, casual, guided, credited, monitored, they all are very important. And then coming back to the lifelong engagement. And once again, AIT's example. So we have academic courses, academic research, sponsored research, lab. We have AIT solutions. We have Asian Center of Engineering, Computation Software. We have a BIM lab. We have an internal lab. We have the clients. We have the consulting partners. We have alumni and professionals. And then everything is linked together while the students are still studying. So when the students in the class, they have exposure to clients, they have exposure to these labs, they have exposure to the consulting firms like AIT Solutions, ESCOMS, and BIM Lab. And now Professional Masters program in Tall Buildings is built on top of that. So we have a program called Professional Masters in Tall Buildings, which is an online program, and people can get a master's degree from home in design of tall buildings, for example. And this has been a very successful feature because people from many parts of the world, in fact, just yesterday, we had 3 graduates of this Professional Master program. They come to AIT to receive their degrees, even though the program was offered. So they are equal graduates in terms of their standing. And now we have added the new ingredient into that one, a new office, CSI Bangkok, which is also located at AIT and part of this whole sort of network and this framework. So I think this is a kind of a good example of how these students are made, given all the skills they need to make them job ready, not only job ready, but also connect them to their jobs while they're still at the university. So they get to work on the software development, they get to use the software, they get to do all the labs, they get to work on the real projects. Projects they give them the data for the research and so on. So these are the sort of examples that I wanted to share how this system can work. Now coming to the personal perspective that I mentioned to you. So this is my picture from 1978, and this is in UET, and I think in one of the Zubair halls or something. And as you can see that I'm working on a drawing with a calculator, with a pen, with a drafting pen. And this at that time, obviously, there is no concept of CAD, computers, or anything that we see here. And this is not too long, it's 45 years ago. And this is all the tools that we have as engineers and as professionals working on our designs. And then I saw this one in 1980. Look at the title of this advertisement. It says, finally, you can afford to satisfy your lust for power. This is a $100 computer at that time, Sinclair Spectrum ZX81. And this had, at that time, it's like, Apple, iPad, all this kind of things. So I bought that while I was in a university and connect that to a TV and bought a tape recorder, voice recorder, connect that to as a storage device because there's no memory. So you store it on an audio tape, and then you connect it to a TV, 12-inch TV, I think I had, and then set up my first computer at that time while in the university. And I remember that this computer with the attached memory has the same memory as our computer in the UET, I think IBM 1130 or something. And we used to use punch cards. We have to go to the lab and use the punch cards to give the program, go next day. Those of you who are my friends and colleagues, they know this. The younger generation may not know. So you do Fortran programming on punch cards. And I could write the same program on my computer in my room and run it in very, very quickly. So I did my bachelor's project on this computer and wrote the first frame analysis program using just 26 variables or a 1K memory or something like that. So the point being is that is the start of the computing at that time. And after that, then everything has just exploded. And my whole career, if you look at that, is influenced by that computer that I bought at that time, because half of my career is now on computer and software development and computer applications and computing related. And most of my jobs related from that onwards have been related to that. So this is just a progression of the career since then, all the way to CSI Bangkok, which is once again an engineering, computer, software development, technology company together with the CSI America. So if you trace back, I can trace it back to this day of getting this computer working. And this is the whole sort of timeline of starting from 1982, since graduating and doing so many things there. And so if I look at my work, because I want to bring it back to the skills that were needed, that I found needed or lacking or valuable in this journey. And that's what I want to share in the next 30 minutes or 15 minutes. So first of all, obviously study, bachelor, master's, PhD, different requirements for skills and knowledge. Then jobs, varied jobs, my own companies, working at AIT, setting up many things, then engineering design of various kinds, entrepreneurship, starting many initiatives, then teaching, academic courses, R&D, software development, professional training, conducting training programs, in all over Asia, thousands of engineers, hundreds of programs, and then research and development, publications, master thesis, PhD thesis, and management as a vice president for AIT, management of the university. So it spreads in many directions. And so if I make this whole, fish bone of the career, it has many branches in every way. So the reason I'm showing this is not to show what has been done, but to show what I found valuable in this one and what I thought I wish I had been taught. And I still wish a few things that I had been taught, which I find still lacking in all of this. So based on that, the first thing that I want to emphasize is the development of the platforms and tools, which I always feel that I should develop for education and profession. And most of these tools or platforms started as something that I wanted to do for myself and then become later other people can also use it. The first one is SDL, Structural Designers Library. And I thought I was running a consulting firm in Pakistan and I needed programs to design beams and slabs and two-way slabs. And Rizwan knows about that. Rizwan Mirza was there at that time. So I said, okay, we should develop programs to do that. And finally convert that into professional programs. We didn't sell many. People didn't want to buy programs at that time. I'm talking about 1980s. But the work done in STL is actually carrying through all the way to the work that I'm doing now. So that's what I want to share, that I think anything that we do doesn't get wasted. And if we do that with a passion right from the beginning, and at that time, I actually put a lot of money from my consulting earning into this one without getting any return, but the returns are coming back over the years. The second one is gear. Once again, this was designed as a gear that engineers can wear to go to job. So this had 30 programs of all kind, engineering, structural, and geotechnical. So whatever they need, they can pull out a program for their pocket and they can use it. So I developed this in AIT and we launched this from ASCOMS. So gear was a very popular program. Ultimately, it was purchased by CSI to be part of their framework. And then we started something called Learn Civil. The idea was that civil engineering students should have a matching app to go with every course that they are learning so that they can experiment, they can visualize, they can simulate the course, they can run their examples, their assignments, and so on. So we said, okay, if you have 10 courses, you have 10 programs, each program attached to each course, or 50 programs, 50 courses, 50 programs. So we started this initiative called Learn Civil. Unfortunately, it was before its time. It was a very long time ago, and we didn't have all these apps and things or the cloud systems to support it. So it didn't go too far. And then we developed AIT Share program for online teaching and online learning. And once again, developed at AIT. And this has become very successful in the sense that our professional master program is actually carried out on AIT Share. So our own platform is used to conduct a full master's program through this platform. So this has been a useful platform that we developed. And this was much before COVID and much before Coursera and all the other people came in. So this was once again ahead of its time in a way that we started this before these big guys came in. And then the professional master's program in tall building that I mentioned. And then we developed CSI apps or computer mobile apps. They are still on the Android and Apple. If you want to go and search, you can still download many of these apps, and they're still working. But somehow we did not go too far in that one as for certain reasons. But now I want to talk to you about this last initiative that we are working on, which I think is very much related to what we are talking about today, the Eagle Eye. So the Eagle Eye project that we have started in CSI Bangkok, and I think this is something that everyone can join. And I invite everyone who is here to think about joining this project in some way, because we are creating a platform for civil engineers and structural engineers to bring in their knowledge and their expertise into this. You can call it an app store, but we will have the platform done so everybody's own knowledge can be integrated and made available to others. And the first level, we want to make it free for education. So we are hoping that this will become a learning platform for civil and structural engineers and will fill the gaps that we find often in our courses, especially from the practical point of view. And this platform will both be an educational learning platform and a professional platform at the same. So it will have 2-3 levels. So we are now working on that, and we hope that this will become, hopefully, the platform for civil and structural engineers to create tools and share knowledge, like an app store for structural engineers. So this is, just on the way, something that we want to do. Now, coming to the skill sets, what is it that we need for doing all of that? And what is it that I find important or missing? Once again, I said this is a personal list, so it may or may not be universal. So I mentioned already, we have challenges in engineering education, balancing fundamentals, foundational with practical, evolving technologies into profession, sustainability and resilience, and societal considerations. So these are the challenges that we can summarize that our education, not only during teaching, but learning after profession address. So these are the 10 core skills that I think are important. Number one, of course, is the core technical skills, the fundamentals that remain essential. There's no running away from that. We have to learn them, and there's no shortcut. Digital and technological skills, the tools for tomorrow. And we see, as I've shown, that it's something, again, that we cannot turn back from this. This wheel cannot be turned back. Sustainability and environmental skills, we have seen how important that is, climate change and all. Once again, this is something that at least it is with us at least for a while. Project management skills, delivering excellence efficiently. And then soft skills, the human element. I think this is the weakest part in our whole setup of engineers compared to many other. I mean, this is something that we stand out as being weak in our soft skills. Business and professional skills, that's another weak area for us. And I think I find that this is something that I wish I could have done better in this one, or done an MBA. And a lot of engineers do that because they find engineering not to be enough. So a lot of engineers who want to go into that, they add an MBA to their qualification. Innovation research skills, very, very important. And global perspective skills. This is, once again, in the present world where you can work offline or online with anyone, global perspective is very, very important. And then future ready skills, adapting to change, and then crisis management. So these are the categories of skills that I think are crucial. Now let's go briefly through each one of them. And this is, it's a kind of a map on how they are related to each other, how each of them depend on each other, and how they enhance or how they require or shape the others. So there's a whole interconnection between these skills. So they can't stand alone. So learning one helps with the others. Core technical skills, I will not talk much about that because I think we cover them well most of the time. So I think depends on subject areas. I think we probably cover them adequately in most of the cases. Digital and technological skill is where I think our current challenge is, because most of us haven't been taught this. Because when we were studying, especially a few years back, these weren't around. So obviously, these are the skills that we need to learn. And from the drafting board that I showed you in my picture to the digital twins, there's a big gap that we have to fill with these digital and technological skills. So that's why today's curriculum heavily integrates computational tools. In fact, sometimes the focus or the balance is not there. I'm working with so many universities, and many universities want to start teaching using ETABS way too early, or they want to start teaching them SAP in the second year or third year of undergraduate program. And we tell them that it's way too early because they will never understand the basics and they will just learn the tool. And the reason the universities want to teach that is because the industry wants these students to have these skills when they go to the office, because they want them to be ready to use the programs. So that's the pressure the universities have. But I think sometimes it's a bit too early to expose the students to these tools, especially the big ones. And that's one of the reasons that we want to develop Eagle Eye with an idea to give them the insight into the tools, not the black box, but something that is more transparent. So BIM, advanced analysis programs, parametric design tools, digital twins, data analytics, programming, so essential. Python and others, I think everyone must relearn. We all used to learn Fortran when we were at our age in these engineering schools. Now it's not taught much because so many languages are there, and Fortran is no longer the base. So now many students come with no coding experience, and that's very important. Cloud-based collaboration tools, AI, machine learning, augmented reality, all of that. So these are some of the digital skills that are now needed in most of the work that engineers are expected to do. And then we can't neglect the entry of the generative AI and the LLMs. I just name a few. There are so many of them. And I think this is the one that has really disrupted everything so rapidly. And if we are not going to adapt, it's going to be a problem for us. And I just give you an example how we can use this. So this is as you know, basically it's an image. It's a colored image as far as the computer graphics is concerned. But if you feed this image to ChatGPT and say, what is it? It can actually give you a very comprehensive analysis of this image, in-depth analysis of what this is. It says it's an interaction diagram, it's a bending moment here, the use of instructional engineering, and the potential application. This is all done by a program which has no knowledge of structural engineering, is not a structural engineer, is just I would say, a dumb language model. And it just takes an image, pixels, information from pixels, and it can interpret all of that. Which means that the potential of using the LLMs for developing understanding is huge, because it can act as an initial tutor. It can act as a quick way to analyze and understand things. Of course, the danger is it can go completely haywire. It can give wrong information also. So we have to have the ability to do both, to absorb it and also to cross-check it. And if you look at the stores, you see so many AI-based models coming up for doing many things. Most of them are hobbyist level, but people are using them, building their own engineering applications on top of these language models to do certain things by moderating the prompts. So the point is that the AI, use of AI, especially the large language models and the generative AI, is something that we can absolutely take benefit from with a clear understanding. However, there's a lot of danger. People keep asking me, because I talk about AI quite a bit, that will AI take our jobs? Will it replace engineers? And my feeling is not yet. Maybe in the future, but with the current development, probably not. So because our decisions are multifaceted and they are not written down as description, every problem is unique. And it's not something that can be written down as a case study or as a medical diagnosis that can be available. So that's why if you look at that, the ChatGPT can pass the medical, law, and business professional exams, but still cannot pass the professional engineer's exam, cannot even attempt it reasonably. So there is plus and minus on the use of AI as a technology, but clearly it has potential in both directions. So I just want to make sure that we do not ignore it because everyone else is doing it, and somebody might come up with the AI model that will hurt our profession or our job. So we should be in charge of doing that by ourselves. So civil engineers may learn to be prompt engineers, to effectively interact and make use of the power of these chatbots or related things. So I think this is quite clear that we need to learn the art of doing these prompts. The second one is, fourth one is the sustainability and environmental skills. I think we all already know about that this is something that we have got to pay attention, and probably we are already a bit late because many other disciplines have gone deep into that. Smart cities, sustainability, all of that could have been civil engineering's main focus, but unfortunately, right now, they are not. So sustainable design principles, carbon footprint, green building, climate resilience, resilient design, environmental impact analysis, life cycle assessment, energy efficiency optimization, all of that should be taught in our courses so that we are exposed to these ideas, if not as an expert, but at least someone who can interact and can comment and keep them in as part of the project scope. Then project management. I think we already have in engineering project management. In fact, every discipline has a management equal. So I think it's not something that is missing. I'm just saying that is very important, and it needs more attention probably, because in the end, most of us in a senior level become managers of some kind anyway. So project management skills are essential. That includes planning, risk, cost, quality, contracts, resources, and so on. So agile project management methods. So I think no matter what kind of engineer we are, management skills are essential. Then soft skills, and that's what I think that we are lacking. And let me show you this. I think those of you who know Dr. Ashraf, he was here in Bangkok a while ago, and this is from his talk. And he had just one slide for his whole talk. So he doesn't talk about structural analysis anymore. He doesn't talk about CSI software anymore. He doesn't talk about analysis anymore. He has talked enough about that. He only talks about this one subject. Engineering is about people. And then he demonstrates that, how far we miss this point. And I think his videos are there. You can go and access them. I think he makes a valid point that our ability to interact with others is limited compared to many other disciplines. Architects, for example, they communicate far better. They interact with far better. We have all attended meetings, and we have seen how we struggle as engineers in this particular aspect. And so soft skills are so essential. They include communication, written and verbal, leadership and team management, critical thinking, cross-cultural communication, negotiation, emotional intelligence, conflict resolution. All these things are extremely important because no matter what you're dealing with, you're always dealing with people. And you cannot win an argument only on technical grounds most of the times, especially with the clients, with the people who have different interests. It cannot be only about technical. That sometimes they don't even care about our technical excellence. They care about things that we have to understand. So I think soft skill is one thing that I always find that we need to pay much more attention in our education and learning. Business and professional skills, once again, I find this is very important. In fact, when my class starts every year, a first question I ask the graduates who are already civil engineers from the good universities, why are you here? That means, why are you taking structural engineering? What do you want to do? And they all say, I want to design good structures. I want to have a technical skill. They want to we all talk about the same thing. None of them says, I want to have I want to earn money, or I want to be rich, or I want to have a good career. And in the end, that's what happens. Structural engineers normally end up with not the best financial stability compared to MBAs. And if I ask the same question in MBA class, they will say, I want to make money. I want to make my first million. I want to have a business. I want to do this one. And they do. So I think the business orientation in engineers is lacking. And that also inhibits us in competing in the business environment. Because in whatever we are doing, ultimately, it is related to the business aspects somehow. So even if we don't purely focus on money, money is still needed to what we want to do. So I think that whole mindset is important for engineers to have as part of the training. Financial management, finance is lacking, another subject that we should be learning. And I find, once again, this skill to be very, very important. Innovation and research skills is absolutely, I think we do a lot, but but sometimes it's just too narrow in my view. I showed this picture especially because I still find people doing research on use of rice husk in cement, or using bamboo as a reinforcement. It's good, but the relevance of that has to be looked at in the bigger picture. I think a lot of the research in engineering is still very old-fashioned. When I was a student in engineering, I saw a paper in ACI saying, research on shear strength of concrete beam. Still, people are publishing shear strength of concrete beam after 45 years. So the innovation in research is pretty limited in many areas. So I think that's why we can't compete with aerospace engineering the way that they have done. We can't compete with biomedical engineering, because our research and innovation is still a bit low. There are not many new things coming out of our research. So we have to have research which is data-driven, have to have creative experimental methods, patent and IP. We don't have a lot of patents. We are not taught about patent and IP. We don't create intellectual property as much as many other people do. So I think there's a lot that our engineering profession or civil engineering can do in terms of the innovation and research, and produce more relevant output in terms of the research. And then finally, or almost finally, the global perspective skill. Because we in this time, especially after COVID, people have exposure or have the access to work on projects anywhere. So learning different codes, learning different ways of doing things, learning different cultures, different languages, it all helps a lot. And this whole exposure, outside the country, outside our profession, is very, very critical when we start to interact globally with other professionals, people from outside. And once again, coming back to the AIT, I think one of the benefits I to tell everyone who comes to AIT is this global perspective, because it's a truly international environment which gives them that global perspective immediately, and that I think is valuable. If I have to go back and see what was the most important thing I learned from AIT, is probably this one, and that I think is critical. International standards, cross-border collaboration, cultural sensitivity, very important, global market awareness, and all of that.
Looks like we have again lost our speaker. We are getting in touch. We are getting in touch with him. Inshallah, he will be online soon. Hello. Yes, my coordinator has coordinated Dr. Saab, and he will resume in a minute or so. I'm really sorry for keeping you waiting again, but this is a technical issue, not in our control. Something is lacking at Dr. Saab's end. So inshallah, it will be sorted out soon. Thanks for your patience. The Dr. Saab has joined us again, and he will soon. Yeah, he is there. Dr. Saab is there. Dr. Saab, you can share your screen now again, please.
Yes, so once again, I'm sorry. I think today the technology is not on my side. So I'm just in the last few slides now. I was talking about the global perspective and how this is important in the current context that we talked about. So another one is future ready skills, and this is I actually my talk was about future proofing, and we talked about that quite a bit. So we talked about continuous learning ability, change management, and interdisciplinary collaboration. In fact, once again, I want to give a very good example of NUST, the school that they have developed, which is the interdisciplinary school. I think this is one of the best example of creating these labs that they have. They have about 19 programs under one building. So I think this is a very good initiative in terms of the engineering education, because ultimately the problems currently that we are facing are so large that only one discipline is unable to solve them. And we talked about the energy, the technology adaptation, and so on. So let me just conclude now that so what we engineers, as engineers, we are continuing this journey, and we built with concrete and steel. I think we have been doing that for a long time, and this is it's become like a phrase to describe us, but we need to move to technology and sustainability, and that's a change that we should start thinking about, because, like I mentioned, that civil engineering hasn't really changed if you compare it with many other disciplines, and that's something that we must change, and we should take the leadership to shape the future of society, because I think we have missed that boat a couple of times. And if we miss this boat of technology and sustainability this time, then civil engineering will have a difficult time in the future. So that's my sort of own observation or own things. So I think the best engineers, if we combine the fundamentals with the emerging capabilities so that we can create a lasting impact. And I think that, to me, should be the final goal of our work and the goal of our continuous learning. So with that, I think I will say thank you so much. And I hope that I haven't taken time longer than I was supposed to.
Uh, Thank you very much, Dr. Anwar, for such an insightful lecture, excellent presentation, excellent slides. And now we will start our Q&A session. I have about 8 questions and yeah, about around 8 questions. So I will read the questions one by one, and Dr. Saab, please answer them. Now, the first question is from engineer Mazdam Nawaz. He's asking, how is necessary the theoretical knowledge of structural design of elements for planning engineer?
Yes, first of all, planning engineers, I'm not so sure what he means by the planning engineer. Is he talking about somebody working at a higher level of design, or is he planning in terms of, I'm not quite clear, the planning engineer term that is referred here, but if I can get a little bit more clarification, I could probably answer that more clearly. Planning,
Yeah.
what is the meaning of planning engineer?
I also thought that the question was not directly connected with the topic, but Wazam Saab, if you need any, if you can clarify your question or rephrase it, then I will read it again. Thank you. Second question is from Rizwan Mirza. He's asking, despite the fact that Pakistan is a signatory to the Washington Accord, PSCE has so far failed to make the universities agree to work with it in order to bridge the academia industry gap. Any suggestions on how we can hope to overcome this difficulty?
Rizwan, I think he knows well that I have not been well connected with the process that universities are following in Pakistan. But I think some universities, as far as I know, when I visit universities, are on their own adapting and signing this accord. Isn't that the case? As far as because I think Nust was mentioning that they have already signed this, or it has it to go through PSCE. I'm not so sure about the mechanism. Hello? Yes, that's I think your mic is muted.
I'm sorry. Yes, I was. So the third question is from Muazzam Nawaz. And this is the comment. I really can't understand what he's asking. Let me read it. Gap between theoretical engineering and practical result failure in professional field. Do you understand, Dr. Saab, what he's asking? And then he's again saying, design analysis of structural elements lecture we arrange for chance to refresh basic right on success path of a civil engineer. I think it is just a comment. Would you like to say something on it, Dr. Saab?
I'm sorry, I could not understand. I mean, I would very much would like to comment on this question, but this one, if he's suggesting that we should focus on the component design to be able to bring its effect up to the top level of planning design, then I think what I can just assume that the relationship between the overall cost or the overall plan against each component is that the intent of the question? Because many times I have discussed about this, that when we are looking at the planning of an entire system, at that time the local optimization or local design of individual component it cannot be done without consideration for its usage, and also without consideration of how it is related to the others. So we normally have to deal with them as a group, and then design them so that they can be constructed properly, and the cost effectiveness can be ensured. So I'm not so sure if that is the intent of the question.
I think if engineer Mozzam has further supplementary on the question, he will ask it. So we move to next question. This is from Ahmed Ayub, and he's asking, how can engineering schools better prepare students for the practical challenges they will face in the field?
Correct. So I think this whole discussion has been trying to answer that question, but let me just, because this is a relevant, very important question. The most important thing that I feel is that the engineering schools have their limitations in terms of the design of the courses. They probably have to follow, most of the time, they have to follow a structured approach, and which has been developed over many years. And to make any change requires considerable effort in terms of the university to design the new programs, to get the approvals, get the resources to teach those courses, and then finally to implement it. So I think it takes several years before a new course or a new method or a new pedagogy can be introduced into a courses. And by the time it comes back, that particular demand may already have moved on. And this is a challenge that most of the universities have, that it's hard for them to make it relevant, make the core education relevant to the needs of the profession. That's why many universities have introduced the continuing education centers, where they provide short-term training programs on topics that the students can take while they are studying, or they can come back as alumni to upgrade their knowledge. So I think that is the best model. And these are skill-based, and these are topic-based, and these are based on the demands of the industry. So especially in AIT, in many universities, they do a lot of these continuing education programs, short-term training programs, seminars, diplomas that can add value to the traditional academic programs, which are very difficult to modify at regular intervals.
Thank you, Dr. Next question is from Rizwan Mirza. He's asking, would you agree that the approach to civil engineering education should ideally be something similar to bedside teaching of medical education?
Yes, I think I completely agree with that, with that idea, that we lack. First of all, let me give you a couple of things on that. First of all, we probably lack an exposure to the students right from the beginning in terms of the significance of what they are going to do and what has been done. And I want to equate it to architecture a little bit once again, because they teach history of architecture for several semesters. So every architect is aware of what projects have been done, significant, who are the people, how they did that. So history is taught as a way to expose them to what the profession has done or can do. And medical profession does the same way by exposing them to the patients while they are being taught. And we don't have a similar mechanism in civil engineering. And I think that needs to happen so that engineers are well exposed to what they are expected to do, what has been done, how it has been done. But the problem is always going to be we don't have enough time in 4 years. That's why medical, residency takes another 2-3 years. Architecture is 5 years. So to do all of that, we probably have to extend the duration of civil engineering to be 5 years at least, to be able to accommodate this particular additional, otherwise we will miss out on some of the core fundamentals.
Thank you, Doctor. Now I have 3 questions, 2 from Shazeb Khalid and 1 from Ahmed Ayub. All the 3 are interconnected. So, Doctor, I will read all the 3 questions one by one, and it will be better that these are huge questions, and I would like you to just, already you have, I think already in your lecture, you have answered these questions, but just briefly, if you can give your reply to these 3 questions. First one is from Shazeb Khalid. He's asking what gaps exist between the academic curriculum in Pakistani universities and the practical demands of the industry. This is the first one. Second question from Shazib Khalid is what strategies would you recommend for civil engineers to stay adaptable in the face of rapid industry changes? And the third question is almost similar by Ahmed Ayub. He's asking how can civil engineers stay adaptable and resilient in the rapidly changing industrial landscape. Yes, sir.
Yeah, correct. I think the whole talk was geared to trying to answer this
Exactly.
question. So
Exactly.
if the questions still remain,
Yeah.
if the questions still remain that I haven't probably done it justice and probably haven't explained, but let me just give it another try to address all of this. First of all, the first part of the question is the university education versus the expectation of the industry. And you see, the problem there is civil engineering is a broad subject, is a broad discipline with multiple things. Somebody, and depending upon what job they do, that particular subject may not have been the focus of the student. I want to give you an interesting story about this one. When I started my company in Pakistan a long time ago, I had several graduates from the university join, and I gave them a project in which they were supposed to design a house with two-way slabs and one-way slabs. And one engineer, he designed all the one-way slabs, but didn't design any of the two-way slabs. And I asked him, what happened? You haven't finished the project. And he said, oh, when they taught two-way slabs, I didn't attend this process, so I don't have the knowledge to design two-way slabs. So that's the kind of, to me, the limitation that universities cannot teach every single problem solution in the limited time they have. And also because of the wide range of things that civil engineers do, it's hard to prepare every geotechnical or water or irrigation or structural engineer from the civil engineering 4 years course. So I think the some level of learning has to be done on the job. What the universities can do and should do is to instill the ability to learn. So I think that's the key. The students should be able, they have the ability to learn rapidly. And with these current environment, with these language models and ChatGPTs and all, there's a huge opportunity to quickly learn if we know what we are looking for. So I think that can fill that gap, that if you're missing a particular knowledge, skill, not skill, a knowledge, that can easily be learned. For the skills, once again, there are a large number of courses online available. The computer industry almost entirely works on online training programs. They learn their skills through that because computer science doesn't teach programming. When they go to the job, they need to do programming and they learn it on the job or by themselves. So I think a lot of that can be done in our profession also. So universities, I don't think they can ever provide all the detailed knowledge needed for a job, but they should provide the skill to learn and the basic skills to communicate the work and to sort of, and the exposure, I think is very important for the students to have. So I think both of them are related, and I hope that I covered them both.
Yeah, I think you did it very well. So now the last question is from Rizwan Mirza again. And he's asking, with some of us at least partially aware of the challenges that have been discussed, there is a sense of helplessness in contributing to rectify the situation. Here in Pakistan, how can we working in the industry contribute under the circumstances?
Yeah, I completely understand what Rizwan is saying because knowing him for so long and having experienced the same sort of frustration when I was there at some point, I do understand that feeling. And in my view, the best way that I feel is to reach out, collaborate outside, and have a little bit of the global perspective on things and absorb something from there. And at the same time, now that the world is quite open to online or collaborative work, I think get involved in the international projects. So we have the sense of contributing to that and our skills and our knowledge in that more and open environment. And at the same time, I also feel that there are pockets of, because I go to Pakistan now, frequently. We have decided to open our own office at NUST, which we opened last couple of weeks ago. So we want to have a presence in Pakistan, and to address some of these things. I think it's time for us to help and contribute in that, and to have this bridge between engineers and companies in Pakistan and here. So, and also universities in Pakistan and here. I've been doing that for a long time through AIT, but through now, I still want that there's more that we can do. So I think moving out a little bit, working outside, collaborating outwards, and then finding those pockets of acceptability in Pakistan, which I think exist, will help because we have got to continue an effort to do that, and that's all I can say.
Thank you, Dr. Saab. I did announce that Rizwan's question is going to be the last one, but one question has come from a very young engineer, Shahzeb Khalid, and I can't resist to ask this question. So though I'm hard pressed with the time, but I think it's a pertinent question, and this should be, if you want, you can answer it very briefly. Should faculty members be required to have a prior field experience to effectively teach civil engineering? As in Pakistan, mostly teachers are not field experienced.
Yes, I think this is a very, very good question. And you made the right decision to not neglect this. I think it depends a lot on the subject areas, and maybe not all subject areas require a prior exposure to the industry, but some subjects which are applied, they should encourage the faculty to work with industry. And a lot of universities now have those those centers where your faculty can work with the industry while they're teaching and bring that knowledge back. And also some subjects, they should require that the person has if it is a design course, I think, or it's a course about management, or if it's a course about construction, or if it's a course that is very applied, then the prior experience, field experience, should be part of the qualification, in my opinion. Like MBA. I think MBA, we should learn something from MBA, the way MBA is taught, because almost all their faculty come from industry. In AIT, we have 48 faculty members in teaching MBA. Out of them, 40 are from the industry, only 8 are from the university. So that's, I think, and that's why when these graduates go out MBA, they are fully prepared because they were taught by the industry leaders and by the industry people who are working with the practical knowledge. So I think that's, we have got to have this idea of having, adjunct faculty, inviting people to come in, teach courses, especially the applied ones.
Thank you very much, Dr. Saab. As we bring this insightful session to a close, I would like to express my sincere gratitude to everyone who made this webinar a success. First and foremost, thank you to you, Dr. Saab, our distinguished speaker, for sharing your expertise and delivering such an engaging and thought-provoking presentation. The knowledge and insights you have provided today have undoubtedly enriched our understanding on the topic you were speaking. Thank you very much again. So before I conclude everything, I would like to inform the audience that today I cannot give you the the topic and the speaker of next lecture, because today is the 13th and final lecture of the year 2024. We are currently finalizing the lineup of speakers and lectures for 2025, and further details regarding the next lecture would be announced in the coming weeks. Regarding your certificates, Dr. Saab, your shield and your certificate will be dispatched to you by Sadia, inshallah, in a week or so. And just adding the add courier time in 1 week, inshallah, by that time you will receive your shield and your certificate. And audience can collect their certificates from 19th December onwards from our office 14A1 Block P, Model Town Extension, Lahore. And before coming to collect your certificate, if you want to ensure that it is ready, please call Ahmad Akram on 0347 462 5111. And before saying goodbye, I encourage everyone who has not yet become an associate of our society to consider joining. It's simple to become an associate, and the procedure is outlined on our website www.psce.org.pk. The annual fee is minimal. It's just covering only our administrative costs. I think it is 1,000 rupees for a year, or if I'm not mistaken, it's 1,000 rupees for 2 years. By joining PSCE, you will also have the opportunity to contribute to the civil engineering profession through our various committees, where you can actively serve and support our shared goals. So that brings today's program to a close. And before we end, I want to give special thanks to my team working behind the scenes. Hasnan is the IT person, and Sadia Naveed is our coordinating officer. And I hope you enjoyed this broadcast, quality of this broadcast. So I will see you now in in January next year. By that time, Allah Hafiz. Dr. Saab, God bless you.
Gosh, great. Thank you so much, Deepak. It was really been, it's an honor and a pleasure. Thank you so much.